Compounds composed of metals and nonmetals are called ionic compounds. Remember that metals form cations, that is, ions with a positive charge, and nonmetals form anions, or ions with a negative charge. Ionic compounds are neutral, meaning that all of the positive charge must equal the negative charge. So let's look at some examples. What happens when we form an ionic compound between potassium and chlorine? Potassium is a metal with the charge +1 because it's in group 1 of the periodic table. And chlorine forms the chloride ion with a charge of -1 because it's in group 7 of the periodic table. We have one plus charge and we have one minus charge. And so when we put these two together as KCl, our charges will cancel out. When potassium and chlorine form an ionic compound, the formula is KCl. Now, how do we name this compound? Well, we keep the name of the metal as is, and we change the end of the anion to IDE. So this compound is called potassium chloride. What is the ionic compound that is formed between calcium and oxygen? Well, calcium forms an ion with a 2+ charge because it's in group 2 of the periodic table. And oxygen forms an ion with a 2- charge because it is in group 6 of the periodic table. So we get 2 positive charges and 2 negative charges. And if we put calcium and oxygen together, those will cancel out. To name this compound, we keep the metal with the same name, so calcium, and we have to change the ending of the anion to IDE. This one's a little different. It's called oxide. So CaO is the formula, calcium oxide. Okay, what is the formula for the ionic compound that is formed between magnesium and fluorine? Let's write our ions. Magnesium forms an ion with a 2+ charge, and fluorine forms an ion with a -1 charge, which means we'll have 2 pluses and only 1 minus. If we put the compound together like this, our charges will not cancel because 2 plus a -1 would still leave us with an overall charge of +1, and that's not what we want. Instead, we need to have another fluorine so that our 2 positive charges can cancel out with 2 negative charges. So we add a subscript to indicate that we need 2 fluorine atoms. Now, all of our charges cancel. And we name this compound just like the others, magnesium. And we change the ending of the fluorine to IDE to get magnesium fluoride. For our last example, let's look at the ionic compound that is formed between barium and nitrogen. We know that barium forms an ion with a 2+ charge, and nitrogen will form an ion with a 3- charge. So we have +2 and -3. And if I put Ba and N together, notice that our charges do not cancel out. we're going to need some more barium ions and some more nitrogen anions. So if I have 3 barium and 2 nitrogen, then I'll get a total here of +6, and I would get a total here of -6, which would cancel out. And so I need 3 barium and 2 nitrogen. And the name of this ionic compound is barium. Remember, we changed the name to IDE nitride. So to summarize, ionic compounds are made by combining a metal and a nonmetal, or a cation and an anion. All ionic compounds are neutral, meaning that all the positive charge must equal all the negative charge. There's one other trick that I can show you to help you write ionic compounds. If we come back and look at our magnesium fluoride example, notice that once we write our ions, we can see a pattern in the formula. The charge on the cation becomes the subscript for the anion. Remember that it's just like there's a 1 here, and so you have a 1 here and a 1 here. If we look at our barium nitride example, we see the same thing. The charge for the anion became the subscript for the cation, and the charge on the cation became the subscript on the anion. I hope that helps.